So we should be good to go. Okay. So the first question we have to ask is why are, oh, come on. Oops. Something got. So it's called privacy preserving natural language processing. So the first question is like, what is privacy? And why should we care about privacy? Oh. So who cares? Who of you cares about privacy? Raise your hand, like be proud of it. Okay. Is it that's why you're here? Or who cares about natural language processing? Okay, so yeah, okay, good. So what is privacy for you? I'm just curious. What is privacy? What does it mean like if you care about privacy? Does it mean like you don't have WhatsApp? So who has WhatsApp? Okay, interesting. Okay, who's using Signal or Threema instead? Who's using Threema? Oh, okay, I am. Who's using Signal? Interesting. Okay, and maybe other stuff. Okay. So why should we care? So we answer this question. So maybe we don't have to spend time on that. But what is privacy? We should spend some time. So today, this is like introduction lecture. We'll talk a little bit about privacy, a little bit about why should we care about it, and then about some Orga stuff like what this course will be about, how we're gonna structure and stuff like that. Okay. So but first, let's get motivated a little bit. Although you're motivated already. So defining privacy. So I'm pretty sure there are courses here at this university who talk about privacy. So maybe you took one of those already. I didn't. I'm not aware of them that much, but I just try to get together a couple of let's say philosophical thoughts about privacy from in the last couple of centuries to see what's out there, because it's a term and maybe there's a definition. So, and as it turns out, well, people actually had a hard time of defining privacy for many reasons, as we will see, but if you think about it, like privacy is kind of simple, Well, if you describe something as private, it's understood by everyone, right? If I say like, well, that's my private thing, you shouldn't care about it. You understand what I mean. But to define it, it's kind of hard. So we call something private that belongs to us and that is kept separate from others, such as maybe our homes, thoughts, feelings, family life. So here we're using basically a descriptive meaning of this word. So we're kind of give it some sort of adjectives and describing what this thing is about actually, how it happens in reality. Okay, so yeah, it's pretty clear. Or we also emphasize how things should be or it shouldn't be. So actually, private things should not be accessed by others, and maybe not like by the general public. So if you have something private, whatever it is, what could be a private thing? That's interesting. So what could be private thing? Why do you have a Signal? What is private for you?
I don't have the biggest trust in the Facebook company and in WhatsApp. Or maybe like some pictures that I send to friends of passwords.
Yeah, okay. So passwords. Okay, so this is interesting. So passwords to me is something like passwords are secret. Like so secret things are really secret, like PIN for my credit card or passwords. Private things maybe secrets or maybe not. I mean, to me, and now you see like how kind of difficult it is to define privacy and private things. But maybe your pictures. Okay, so for you the pictures are private. Okay, cool. So if it's pictures are private, it belongs to us, or maybe to you and your friends, and we kind of get to decide what happens with them. So we're using the kind of like normative meaning of the word, which is how things should be, how the norms are, what the norms are. So it's basically a philosophical treatment of privacy. So there's lots of research, and I'm always putting these references here. If you want to look up any of those references, I mean, they're not obligatory to read, so this is a book. If you struggle accessing that, then just ask me, I'll send you PDF, okay, in the worst case. But these should be like public sources. I guess these actually today are not public, like publicly on the internet, maybe in the library. Okay? So these are two, privacy is, we're trying to define it. And it didn't start in 1890, but one of those first kind of notion of privacy from the law perspective was by this author called Warren and Brandeis, and they put this paper out in 1890 saying that was kind of famous quote is the privacy is the right to be let alone. So no, if there's something private, nobody should should care about it. Like, leave me alone. This is my right to privacy. Leave me alone. And this is like a freedom from other people or some other kind of subjects to intervene with you. Okay, so, and I think they here also meant the press. So, you know, if press is kind of coming after you, you have the right to be left alone and just, you know, nobody's interested in my personal stuff. And it kind of kicked off the conversation on how to define privacy in law and beyond. So if you're interested in the history of privacy, just go there. Maybe you're not. So, and things have evolved into another kind of influential definitions of privacy, which is the claim of individuals, groups, or institutions. So it's interesting. This goes beyond, well, individuals are clear, it's a person. But now we're talking about privacy of groups or institutions. So like, I don't know, University of Paderborn has some right to privacy. Wow. So what does it mean? It's interesting, like institutions has some right to privacy to determine for themselves when, how, and to what extent information, now we're talking about information, okay, general term, about them is communicated to others. So I believe this comes, at least in my understanding, comes really closer to what we understand as privacy now. Like we have some information as an individual, as a group of people, as an institution, and we want to control when and how and under what circumstances it gets sort of leaked or communicated to others. This is similar, like you don't trust Facebook, you want to control your own things with your group, which you kind of, the control is given in this case by not using their platform, for example, okay? Yeah. So this is one of the definitions. And of course, it evolved over time. Now to control, like here, the focus is more control. So informational privacy is defined as an individual's ability to control the initial release of information about themselves and its subsequent distribution and use. So why do you think the focus here is on initial release? Why should we care about initial release? Why is it important? Yes.
Public can be copied, and then it's irrelevant.
Yeah, exactly. When it leaves you, you lose control. When it leaves you, it's gone forever. You cannot undo. That's whatever we do, whatever we put on the world, will be there, no matter how hard we try, how hard we try to delete things. Remember, you know, whatever you put on the internet will stay on the internet. And still people are, you know, posting stuff on the internet which shouldn't be posted in the first place. Anyway, so this is about the control, like initial release, of course. Once, you know, as long as you have something private, like nobody should know, keep it private. Once, and you can decide when to release. Once you let it go, it's gone. I think it's common sense, but I think it's interesting, like, to see these perspectives, how they change over time. Okay. And so what is the takeaways? Yeah, general definitions of privacy are manifold. So there's many of them. Over time, they have been refined, adapted, and adjusted. And it looks like defining privacy for everyone under any circumstances, like it's impossible, you know, because maybe the word is just so ambiguous and everybody understands different angles of that and different perspectives, then it makes no sense to define it for all cases, although people try. So if you're interested in this evolution, this is one of the books you might look up, or the first chapter, at least, for this book, if you're interested in philosophy of privacy. I don't think you're interested in philosophy of privacy because most of the, so computer science, so what do you study? Computer science? And you have also like computer science, visual informatic. Okay. So anybody's doing philosophy here? No, okay. There are studies in philosophy. What we are interested more in this course and in general is technical stuff, basically. How to implement privacy, you know, how to build stuff and how to take control and blah, blah, blah. Okay, so, but I think it's important to start with this definition of privacy, that whatever perspective you take on privacy and whatever definition you take, well, this is not the only one, and maybe this is not the only one correct. There's, you know, multitude of them. So keep that in mind, because what I see in other courses, maybe on, I don't know, like private data analysis or differential privacy, like, okay, privacy is this thing, set in stone, and just let's do the math. But yeah, maybe, like, it's a social construct. Everybody agreed on, like one definition, one kind of formalization. So you can take it for granted, but you don't have to. Okay. Any questions? It feels like a lecture. It feels like I'm talking quite a lot. I mean, yeah, I'm trying to get it interactive more. But now, I mean, this is more like, exposure to the topic. Okay. So any questions? Yeah, we're good to go. Maybe we don't need any definition. I guess we need some at least. So privacy is easy, right? Yeah, I found this picture somewhere online. So we just, standard thing, privacy is easy to screw up. I think this actually happened. I mean, I saw it somewhere on Twitter or whatever, So just again, like this person is blurred picture, and I think it's some sort like maybe she's a victim or something. I don't know. I mean, I tried to Google up again the picture, but there's no information. But I guess they kind of interviewed somebody who was involved in something not maybe necessarily nice, and they, this is this person again on the second picture. So privacy is really, 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 really hard to do right, as we will see. Okay, so this is one. I mean, this is obviously like somebody screwed up their job at the television. Okay, but as we will see, it's it's when things go wrong. So we don't know what privacy is. I mean, we had a couple of definitions, but now let's take the other perspective and let's show a couple of examples when privacy actually goes wrong. So what it means, and we will see like, oh yeah, I know what privacy is when I lose it. So the Netflix on the competition. Anybody heard of this Netflix competition, like $1 million prize from Netflix? So Netflix, everybody knows Netflix, right? So Netflix streaming platform. And some 18 years back, they announced the $1 million competition for improving the movie recommendation service. Okay, so they want to, they want to better, well, they want more money. So they wanted to make a better recommendation for you to, which next movie you should watch. And they wanted to improve this by making a prize public, and whoever makes the best system will win, $1 million. It's something like Kaggle. Do you know Kaggle? Is there someone who doesn't know Kaggle? Everybody knows Kaggle? Okay, so it's like basically a Kaggle competition. So whoever gets the best score kind of wins $1 million here. And in order to give some data, they released, okay, this is 100 million movie ratings. This is interesting. So created by 500,000 users, subscribers, so Netflix users over, wow, that's long. That's 6 years. So back then it was like one over 8 of their customers, so 10%, not the full database. They 500,000 subscribers, data, and they have the rating. So overall, some 100 million ratings. And apparently the ratings data, they were just left intact. So so what does it mean, the rating on Netflix? Like you watch a movie and you give it a star, right? I mean, 1 to 5 stars. It's like who has Netflix? So what do?
You can do a thumbs down, thumbs up, and double thumbs up.
Okay, so thumbs down, thumbs up, and double thumbs up. I think they had some stars, at least back in this case study. But okay, so you vote for the movie, like it, didn't like it, and so they kept this kind of like intact. And of course, I mean, if you release data about users, what are you gonna do? If you are Netflix and say like, well, I wanna release 500,000 people watching preferences for movies, so what are you gonna do? So what do you need to do? How can you make this somehow like anonymous? What are you gonna do? You have your database of customers, name, address, email address, credit card number, and movies. So what you gonna do with this if you wanna release that? I mean, if you wanna release it as it is, you will go to jail, nowadays at least. But even back then, like before GDPR. So what you gonna do? You will drop all personal information. Okay, sounds great. Sounds like a good idea. So how exactly you gonna do that? Every user has an identifier, okay?
For every personal information, for example, email address, credit card information, and I would remove them from the data set.
I see. Okay, so you would basically keep only like some sort of like ID for each user, but deleting the name and deleting the credit card and stuff like that. Pseudonym. Okay, so it's pseudonymization. Okay, so who agrees with that? I mean, who would do that? Okay, 1, 2, sort of, 3. Okay, good. Yeah, that's what I did. Of course, like, of course, just there's no names. So who cares? Like, there's an ID and there's movie watched by some random ID. So what you want to do is in this recommendation is to find another IDs which kind of you can recommend the movies, like, you know, based on the others. Sounds fine. I mean, sounds okay, right? Is there anything to lose? Well, we will see. Yeah, there maybe. Okay, so you can change the movie names. Okay, that's okay. That's good. That's even better. So how would you do that? Okay. Right. Okay. So you can change the movie names into IDs. Yeah, that sounds also. I'm not sure if they did that. Maybe they did. Maybe they didn't. I don't know. So, but it sounds also like you have like IDs here, and then there's some ratings in between. Okay, sounds good. Sounds well. Okay. So exactly that's what I did. Removing the information from the records is not well. Okay, so turned out, surprise, surprise, in this beautiful paper by Narayatan and Shmatikov, that it's not sufficient for anonymity because guess what? You remember you remember this picture of this woman, blurred face, and on the next picture she didn't have a blurred face, right? So even if you blur one face, you know, one instance, there is some sort of like auxiliary or other information which you can use like to identify the person. You just link these two pictures together and you know like this is the person. Okay, this is the same principle they used here. So auxiliary information about some subscribers' movie preferences. So you can use this auxiliary information. We will talk about it, what they actually did. So you can use the titles of few of the movies that the subscriber watched and whether the person liked them or not, and maybe when they watched them. So this would be our auxiliary information, which we will use to try to find something about the person in the Netflix database. And the question is, how much of the adversary or auxiliary information a bad guy, so the adversary, needs to know about Netflix subscriber in order to identify her record in the data set and thus learn the complete movie viewing history. Okay, so we have some auxiliary information. Maybe we know something like some people watched some movies and rated them. This is our auxiliary information, something. And then we have this true data set from Netflix, which is anonymized, which also has like persons and their movies, but maybe not all of them, right? So maybe they just release, well, actually, no, they release all of them. Like if a person watched 10 movies, there would be like 10 entries. But maybe there's some other information that people watch movies and rate them, which is much smaller, but still could be helpful. So what can you use what would you use as auxiliary information? Can you use something that will tell you that some persons watched movies and gave them rating if you're a bad guy? Is there anything on the world that tells you like how people, which movies people watch, public information, which people watch which movies and how did they like them?
There might be information on rating sites on the internet.
Rating sites on the internet, do you know any?
Like
IMDb. Okay, so what is IMDb? Everybody knows IMDb? The Internet Movie Database. What is IMDb? IMDb is movies, of course, and user profiles. Some of them have whatever nicknames. Some of them are like just maybe I'm a like a journalist or movie reviewer or whatever. Full names. And what they have, reviewing movies. You give stars and maybe you write a review. Okay. Yes. And that's what they did. So this is going to be IMDb. where you have the same thing as in the Netflix dataset. So the Netflix dataset would be basically a table where you have n users and movies, and here's like, yeah, like it, didn't like it, how was it? Like it very much, like 2. Okay, so something like that. And all of them, and in IMDb, you have also some sort of number of users. So maybe, I don't know, Q, some users like P, and 1, -1, and 2. And guess what? You will find some overlap. And this overlap will help you to identify these people in the Netflix database. Okay? This is auxiliary information. So no matter how hard you try here, no names and no movie things, you can still somehow find a mapping between some values here. And once you find the mapping, things will open up for you. Okay, any questions? Does it make sense? Yeah. So exactly, I just described what is the microdata. So microdata is a data set containing specific individuals, which is, I mean, you can see it as a table. So microdata is a table, and each row is a person, and it has some like attributes. And microdata is kind of cool, like to share, because public things, and we will see a couple of examples. But even if identify information such as names, addresses, social security numbers has been removed, the adversary can use contextual and background knowledge. So in our case was IMDb, as well as cross-correlation with publicly available databases to re-identify individual data records. So this is the attack, these people, Narayan and Shpatikov used for this attack. And the microdata, as we saw, is high dimensional and sparse. So what does it mean, like high dimensional? Okay, so let's think about it. Here we have n users. So what was n? How many users we have in the database? It was like 500,000, right? So 500,000. And here, how many movies is there in the, like, how many movies is on the world in Netflix? How many movies Netflix has? Estimate, roughly, like, I don't know. Any suggestions? How many movies? That's 20,000, which, well, it's kind of, it's not much, right? I mean, 20,000, you can watch it in your, no, maybe not. I don't know, let's say, I don't know, 100,000, maybe like 500,000 movies. That's maybe too much. So let's say like 100K movies, okay? Roughly, I don't know, something like that. So, and you cannot, of course, you won't watch, none of the users will watch all these 100K movies. They will just watch a few, right? 10, 20, 100 movies, whatever. Which means there will be only a few things here which are rated, and the rest will be just empty, sparse, okay? So, which means we have many attributes. So the attributes are the columns. And we have a pair of random records are located far apart in the multidimensional space. So basically, this would be one vector of one person, and here this would be another vector in another person. And this will be very, very different, like in this multidimensional space, because you have 100,000 dimensions. Only few will be ones, and the rest will be zeros. But still, the sparsity will kind of, there will be like very few similarities between what people watch. Okay, that makes sense? Okay. Which is a bad thing, because it helps you to, once you find this matching of the sparse vectors, it will help you to identify these persons. Okay. So again, database is n times n matrix, and each row is associated with some individual, and columns are attributes. And the values, actually, in their attack, they didn't consider only like Boolean or integer. It could be anything, some sort of value, like didn't like, or -1, 1, 2, or something like that. Okay. And the number of attributes or columns is the total number of items. So few thousands for movies. Okay, maybe it wasn't 500,000. Maybe it was like, maybe you were right. 20,000 maybe like large. Can somebody check how many? Okay, so you have laptops. How many movies are on the world? Netflix. How many? You have ChatGPT. How many movies are in Netflix?
17,000.
17,000. Oh, that's not much. Okay. Well, I thought there's more movies. 2020, yeah, okay. So 17K movies. Okay. I thought like on Spotify, there is 90 million songs. Can you check how many songs is on Spotify? Just for reference, like, I don't know, how big are these numbers? Are you asking ChatGPT or Google? Sorry?
100 million.
100 million. Okay, yeah. So there's fewer movies than songs. Makes sense. Okay. And of course, I mean, if you're the good guy, you're trying to do the task of collaborative filtering, which is predicting a customer's future choices from his past behavior using the knowledge of what similar customers did. And everybody knows that, like, oh, if you like this movie, you might want to like this movie. If you like this product, you might want to like this product. And I mean, 70,000 is it's a lot. It's like a super high dimensional. Think about like Amazon products. How many products are on Amazon, by the way? I'm sorry for this. I mean, it's just one search in Google apart. Wow. Okay, it's ChatGPT doesn't know, of course. Yeah, 600 million products. Wow. So imagine how hard the task is actually. Like, you have 600 million products, and you want to recommend like only those that kind of make sense for you. Oh, it's a hard task. Collaborative filtering is a hard task. And how it solved this, I don't know, like back then, who won the Netflix competition was some sort of low dimensional projection, something like SVD, if you ever, SVD, single variable decomposition, something like projection to low rank dimensionality. Whatever. We don't care about collaborative filtering, but just the task and the size of the data set. And as the bad guy, as the adversary, we want to de-anonymize an anonymous record R from the public database, and we sample R from the database from the Netflix database and give it a little bit of auxiliary information. So this is a little bit from IMDb, and want to kind of match these two together. So we're kind of thinking that the IMDb has a public profile, and we want to find a full watching history of them from Netflix. So, and the results. Well, okay, this is interesting. So actually, very little auxiliary information is needed for the anonymous and average subscriber. Even just as few as 8 movie ratings, and 2 of them might be completely wrong. And the dates of watching, with some, I don't like, plus minus 1 or 2 weeks. Or no, yeah, exactly. The 14-day error. 99% of records can be uniquely identified in data set. Like, that's a lot. 99% records from 500,000, it's almost 500,000. It's really, 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 really bad. Okay? Agree? Like, this is cool. You have just a few auxiliary information, few. I mean, we're not going to talk about the exact kind of matching algorithm they use. So if you're interested, just have a look in the paper, because it's it's kind of simple. It's heuristics, how to map these things together, and you just play around with data and try to align that. And there are some research challenges as well. So that's why it's sort of like a research paper. But at the end of the day, yeah, guess what? If you release microdata and just pseudo-anonymize them, yeah, maybe there's another data set, and yeah, you're gonna find out some things. And now you might be asking, does privacy of Netflix ratings matter? And you might say, like, yeah, I don't care. I mean, I don't care. I'm just watching what is cool now. What people are watching on Netflix these days. What is like? I used to watch like Game of Thrones, so nobody cares about it. What's now sort of like the hot stuff on Netflix?
Stranger Things.
Stranger Things? It's still running? Ooh, how many seasons are there in that?
Or
Stranger Things. Okay, is it good? It's okay. I'm gonna check your public profile on IMDb. Okay, so yeah. All right. So exactly, I'm watching Stranger Things, as everybody does. I don't care. That's right, But the question is not, does an average Netflix subscriber, as you or me or you, care about privacy of this movie viewing history? Maybe they don't. But is there anyone in the database whose privacy can be compromised by analyzing this release? We don't care about the average. We care like, maybe somebody will get hurt very badly. And the question to that is yes, unfortunately, yes. So what they did here is they experiment with cross-correlating non-anonymous records from the IMDb. Yes, Netflix. It's possible to learn sensitive, non-public information about a person's political or even sexual preferences. Yeah, why? So if you imagine you have IMDb profile, I'm gonna say on IMDb, Stranger Things, series 1, cool. Series 2, oh, didn't like it, and series 3, oh, kind of, it's rubbish now, and that's it. But maybe on Netflix, I watched more, maybe some bad things that nobody should know except for Netflix. Like, yeah, of course, Stranger Things 1, Stranger Things 2, Stranger Things 3, and these ratings would kind of match. And then I watched some bad stuff. I don't know what is bad stuff. The Friends from the 90s, from the 1990s, right? I should be shamed for that because maybe I'm old. But I've heard like it's popular again. Is it? Like anybody? Did you watch Friends? Well, okay. So maybe this is like a tiny little secret and nobody should know. Like, okay. I mean, I watched it like 20 years back. Okay, so the Friends are kind of like, you don't want to watch this because it's like it's not cool anymore. But it's nice. Is it nice? Did you like it? Yeah, you see. Okay, so maybe it's not. But nobody should find out. And now, well, everybody will find out because you can get it from this, from linking this internal Netflix database and the public one. So they did a couple of case studies here, and I'm quoting here from the paper. So consider information that we have been able to deduce by locating one of these users' entire movie viewing history in the Netflix dataset, and that cannot be deduced from his public IMDb ratings. So the person was a male person, obviously, and he watched something, but he watched much more. So first, we can immediately define his political orientation based on his strong opinion about power of terror, Noam Chomsky in our times. I don't know this movie, so maybe is it like right wing? Okay. Fahrenheit 9/11. It's like a conspiracy theory, right? Fahrenheit. Okay. So maybe he's a conspiracy theorist.
Oh, this is also a book. Fahrenheit.
But it's a movie, like okay.
Yeah, that's a bit.
Yeah, this is the movie. I think I saw it. Like, strong guesses about his religious views can be made based on his ratings of Jesus of Nazareth. So, of course, I mean, he's maybe religious, and the Gospel of John. Okay, so maybe he's religious, sort of left-wing religious is okay. Why not? He didn't like Super Size Me. Okay, I saw this. It's like the Big Mac thing, right? I mean, the guy is eating only Big Mac and everything. Yeah, it's a pretty scary movie actually, or documentary. So at all, perhaps this implies something about his physical size. Okay, so we're learning something about this person just by what the person is watching. Both items that we found with predominantly gay themes, band and queer as folk, were rated 1 star out of 5. So he's maybe anti-gay. I don't know any of these movies, by the way. He's a cultish follower of Mystery Science Theater 3000. No idea what that is. Maybe it's bad. I don't know. Anybody knows that? No. Okay, doesn't matter. And this is fun. Like, this is far from all we found about this one person. But having made our point, we will spare the reader further lurid details. Yeah, I mean, we can laugh about it. It's fun. Like, but it's a real thing. Like, somebody, like the company, so you're subscribing to a company and they're saying like, yeah, we keep your data, your data secret and private, whatever. And then they release the data set and say like, yeah, it's public, it's anonymized. Everybody's good. And then these guys came in and just made this attack, and imagine they would release that we watch Friends. So I don't want to. Yeah, no. I mean, we watch Friends. We're good. So yeah, it's pretty bad, right? So you're with me. Not a good thing to happen. Okay. I mean, that's a case clear. Which brings us to this sort of family of these, we call it attack, like privacy attacks, which is called linkage attack. So these are attacks used to re-identify or de-identify data from various sources, including these are examples which actually in this paper are cited with the proper references. So if you are interested in any of those, like how people were able to link telephone metadata, social network connections, health data, online ratings, and mobility data and credit card transactions, just go to this paper on arXiv and find these references to the other papers, just to make it clear, like you should never just anonymize things and put them on the internet. Like never, ever, don't do this. Like if there's a bad guy, they will find out. And these linkage attacks, as we just saw, work by identifying a digital fingerprint in the data and combination, which is like the combination of features that are kind of unique for a person. And if you merge these fingerprints for different sources, you will find who these things are, who these people are. Okay. Any questions? So this is just basically a description of this attack. Okay. So exactly. If two data sets have related records, one person's digital fingerprint should be the same in both, and this is the linking. The thing is that this is not necessarily sophisticated. You know, you can just simply link it with online information, and that's the case of the IMDb thing. Yeah, you don't have to be like a bad hacker. You just, there's some data somewhere on the internet and just link them together, and okay. So shall we continue with something like when things go really, okay, now something completely different, okay? Shall we make a break or just let's go through, right? I mean, I had coffee before we started, so I'm fine. So let's go through. Okay. MBS PBS. So this paper by Culnane, Rubinstein, and Teague, also on arXiv. So it's beautiful read, actually. So in August 2016, pursuing the Australian government's policy of open government data, the Federal Department of Health published online the de-identified. Okay, you see where it's going, right? Longitudinal medical billing records of 10% of Australians, about 2.9 million people. For each selected patient, I mean, I don't know how these people ended up there. Maybe they were just randomly kind of selected. Like 10% of all Australians ended up in this database. For each of those patients, all publicly, excuse me, should be space here, publicly reimbursed medical and pharmaceutical bills for the years 84 to 2014, which is 30 years, were included. Suppliers and patients' IDs were encrypted. Okay, so what is encrypted? Random ID encryption. Okay, so MD5 hash, SHY, whatever. Encrypted, though it was obvious which bills belong to the same person. So now you saw the IMDb attack, like this is much, much, much worse. Why? Because this is health data. Like, and people are kind of, maybe we don't care about friends, but we might care about like things that happen to our bodies and that are actually really, really private. Like even your employees should know about things that, you know, if you go to doctors and you sign up your how's it called? That you're sick, like a sick leave kind of notice. Yeah, in English, like how's it called? Arbeitsunfähigkeit in English, what's the term? Sick leave notice. Let's call it like that, okay? There's nothing about like if you're sick. Like what's the disease you're having or sickness or illness, right? Because of privacy, right? Well, think about it. Okay, so think about it. But there's something on this sick leave notice which is kind of bad. What do you think is it? Which is not really private. Think about it.
What's sick or because isn't note every time an employee is sick, you see he's not there.
Yeah, sure, but it doesn't say anything about a sickness. It doesn't say anything like, well, was it a heart attack or was it just a flu?
But you have the information about which days.
Sure, but that's okay. Yeah, maybe if it's long, this might be something bad. Okay, but there's something worse even in there. Any other idea? Yeah, it's the name of the doctor and the address of the doctor. And guess what? If you go to psychiatry clinic, it will be there. So there will be no the disease on the sick leave note, but there will be like Facharzt für Psychiatrie and blah blah blah. And and I don't think it's good actually. But this is how it is nowadays. You know, that's a true story. I mean, it didn't happen to me, but I know people who are in this field, and you know, that's not a cool thing. So anyway, so even this, and now imagine we have 3 million people who never ever kind of agreed to your data, to my data to be published, and now it turned out to be in this database, which is made public, de-anonymized. So what happened? Yeah. So again, the data set. MBS, PBS. So MBS means medical records, and PBS is prescriptions, 10% of Australian born each year. And for each patient, we have ID, the year of birth, and the gender. Okay, so we have 3 information: year of birth, gender, and some identifier, which is unique for each person. And then we have, for each of them, we have medical events to patient. So the prescription or the service. So, if you got sick with something, everybody will know where the supplier, patient were in date, price paid by the patient, and reimbursed by Medicare, and also who did that. So some sort of like medical history. Maybe it's not like full medical history. It's pretty bad if somebody will find out about you. And here we have what? ID, number, year of birth. And they did some sort of cleaning, like remove some rare events and some perturbation of, again, 2 weeks. Okay, so we saw it in Netflix, like 2 weeks, shift left, shift right. Okay, so what can go wrong? Yeah. This is what they say, the authors of this paper. In September 2016, we decrypted IDs of suppliers, doctors and midwives, and informed the department. So the data set was taken offline. Yeah, so it was a big warning. In this paper, we show that patients can also be re-identified without decryption by linking the unencrypted parts of the record with known information about the individual. So linkage attack again strikes this Alfred. You cannot really control what the adversary knows. And the adversary knows maybe some other stuff. Maybe something public, maybe Wikipedia is enough. So I highly recommend to read this paper. It's kind of like very accessible, very short, because one of the authors tried to find herself in this database because she knew her gender, year of birth, and the location of the doctor. So she kind of she couldn't identify herself. So she wasn't in the data set, but some of her colleagues were in the data set. So she could identify them in there. And it was like, a bad thing. So, and these findings replicate those of similar studies of other data sets. So a few simple, mundane facts taken together are just enough to isolate an individual. And some patients actually were identified by a publicly available information. Of course, if you decrease the precision of the data or just do some perturbation, then it makes the identification harder. So you see here the key, what you have to do with the data. What you have to do, it's not like remove IDs only. You have to do some damage to the data. Okay, you have to damage your microdata. And maybe by damaging the data, it will still be valuable for whatever you do down the road. And maybe it will somehow protect privacy. Okay, you see? So this will be a topic of many of the lectures we will have. You need to somehow do something with the data before releasing some damage. So there will be cost for privacy by losing utility. And we have to find a trade-off. But still, I mean, if you just anonymize and do nothing to the data, yeah, bad things happen. Okay. So is everybody with me like we should care about privacy and this is important? Cool. Because now you might be asking like, oh, this is privacy preserving natural language processing. So where the heck is NLP? Because we're talking about microdata like tables. So do we have anything bad in NLP as well? Yeah, we have a couple of cases, when things were kind of not working as intended. But these are a little bit different from the cases we had before. So let's dive deeper. Okay, so large language models, training data for language models. So state-of-the-art language models are pre-trained on vast text corpora that consists of billions of trillions of tokens. For proprietary models such as GPT-4 or PaLM, I think it's PaLM, is it Google? I guess so. These training sets are kept secret to presumably hide things like the company's proprietary data collection pipeline. So if you're Google and training your model on all emails, that's a proprietary data. I mean, of course, the email, you think your emails belong to you if you use Gmail. Come on. So the second, any private user-specific or licensing training data that is not publicly available. So these are the emails, and maybe these are some, I don't know, internal things. So, okay. Quick poll. So GPT-1, what is GPT? Cool. I guess it's generative transformers. Yeah. So what does it mean to pre-train? I mean, so what I'm asking, like, so how much you know about NLP and how much you don't know. So everybody knows what is a transformer model? So who doesn't know what is a transformer model? Awesome. Okay. So how do you train your transformer model? How do you pre-train it? No, that one. What does pre-training mean? Yeah, but what is exactly like pre-training? Well, why is it called pre-training? So what is the training objective? It's fine to say I forgot, so that's fine. I'm just, I want to understand what you don't know, so maybe I have to explain, because otherwise it makes no sense. So, okay, let me. There's two solutions to that. So, either spend 5 minutes on explaining that, or you will watch the YouTube videos for the course I gave last semester, because it's all on YouTube, and I'll get subscribers and likes. I don't care about it, as I told you, but because we will need some. Maybe I put it on the syllabus. Like, you will need some really, really good understanding of NLP, like, and transfer models. Okay, so if you don't have yet, maybe it's a chance to kind of refresh that, or learn by doing, like, maybe watch a couple of videos from. You don't have to do the full thing, but maybe at least the transformers and SGD. What is SGD? Does it ring a bell? Yeah. Yeah. Okay. So what is it? It's optimizer. Okay. Okay, so it's optimizing parameters of the model. Okay, how is it doing exactly? You want the minimum error. Okay, so we have some objective. You want to optimize, maybe make the error as small as possible, like a loss. We call it a loss. So you want to minimize the loss. Okay, and how exactly you come to this kind of minimum thing? How do you get there? Okay, yeah. Learning rate is there's a term called learning rate. Yes. So remember, like stochastic gradient descent. So stochastic is a thing, gradient is a thing, and descent is a thing. They will tell you exactly what it's doing. So gradient means, so what is a gradient? What is a gradient? It's a slope. Okay, so it's a slope of the loss function. Okay, cool. So we're getting somewhere. Good. So you have your loss function, which is like very kind of multidimensional thing, and you're at some point and you want to minimize it, so you take a gradient. Okay, if you don't know what is a gradient, look it up. It's a really important concept. We'll talk about later. So you have a gradient. Descent means you go in the direction of, like, the opposite of the steepest gradient, so you get somewhere. In stochastic, what is stochastic in stochastic gradient descent? I know you know. I want to hear somebody. You had a lecture. I know you already. So no. Anyone else? What is stochastic doing? Yes. It's not random. It's not really random move. It's actually the opposite of random move. It's very kind of. No, not really. It's not a small step. Not really. No. You know why it's not random move? Because you have the gradient is telling you where to go. Exactly. So it's not random at all. So where the randomness is coming from? I think you're getting somewhere. Okay, so you don't have information of all data. It's kind of, it's not actually, what is it? It's not the exact direction of the loss over the whole data set, but no. Stochastic means you want to optimize the loss of your entire training data set, but your entire training data set is just too big to fit in whatever you're doing. So is it the size problem? I guess so, yeah. But you would have to, no, it's not a size, it's a computation problem, because you would need to compute the gradient for each example and then average over all of them. This will give you like the best estimate of the gradient for the entire data set. So you say, yeah, I'm gonna sample a small sub batch of this data set randomly, which gives me some sort of estimate of the gradient. And that's why is it stochastic? We randomly sample a mini batch. So mini batch stochastic gradient descent, or stochastic means actually, sorry, stochastic means you take a random sample at a time and do the update. That's stochastic gradient descent. This is very slow because you take just one at a time and just go somewhere random. Well, not random, but by one random example. So maybe you want to have the best out of two worlds and you sample a random subset of the data set, which gives you some sort of estimate of the, of the gradient. And it's also a memory issue because we are running things in parallel, so they have to fit in the GPU. So okay, we're getting somewhere. Sorry if it's confusing to you. I really recommend to watch one of these lectures on NLP. And if it's refreshing for you, that's great. So we're getting somewhere, like finding the common denominator. So pre-trained means that. So what is the training objective of pre-training objective, or even like training objective of GPT? So how is it trained? What does it mean, training? How do you train GPT? Okay, so what do you need? What do you need for training GPT? Sure, guys. Sorry, I don't want to be sarcastic. Like, yes, data, of course, but I mean, what kind of data? Okay.
Like, if it's a training data like on text, then we are doing the textual.
Okay. Or? Okay, so it's called self-supervised learning because you're predicting the next token. Okay, so this is your objective. The actual objective of training GPT is where it's not it's token. Yeah, it's not a word. It's token or subword unit. The actual objective is given a couple of tokens, you predict the next one. So that's why it's called language model, because language modeling comes from Ngram language models, in early 2000 or even before, 1980s. So you predict the next word, and the actual prediction is classification into one of, into getting probability distribution over vocabulary. So you have vocabulary. Vocabulary is a sort of like inventory of tokens, and you want to predict the probability of the next token, or what is the probability of this particular token, and so on for the next word. This is what you're doing. Why is it called self-supervised? Because you get the data for free by basically chunking your text into pieces and saying, well, this is the input and this is the prediction. So you don't have any labels. You don't have to do anything manual. You just do it like self-supervised. Okay, so this is very important. And the more data you have for this learning, the better it will learn the language model, like what comes next. And by doing so, turned out that the transform models are actually kind of good in learning just more than like next word prediction, but even something like about semantic, lexical semantic, then semantic, reasoning, logic maybe. The bigger, the better, the merrier, So, but this is how you train it, which means you have trillions of tokens, and basically what you learn is next word prediction is good. By learning so, you will learn something for your task. Okay, so everybody's with me now? If you're not with me, I would ask me. I mean, you can ask any questions. Anything is unclear on this pre-training of GPT? Sounds good. So, and of course, you need more data for pre-training these things. And there is something called domain adaptation as well. Well, not domain adaptation, but there are domains of data you can pre-train the model on. And for example, if you want your model to work more on legal data, you want to pre-train maybe on your legal documents like contracts or whatever, and they might be kind of proprietary. So, and that's actually like a real case. Like if you're a big company, I don't know, Westlaw or Thomson Reuters, whatever, you have like lots of documents and you want to pre-train your model, but they are private, so you want to keep that. Okay, so what happens with LLMs? Is that they not only learn something about language, but they tend to remember things. And they tend to remember things such that they actually memorize the training data. If you have really big model, what is big? What is big model? How many parameters are in the model? What is big? Millions, billions. Okay, well, a lot of parameters. So who is for a million parameters? Second? 100 billion parameters is big model. But I guess these are, I mean, we have, what is it? 7 billion llama, 13 billion llama, and 70 billion llama. So, okay, what is a parameter in language model? What is a parameter? Why is it called parameter? What is parameter in language model? Yeah.
It's a single weight of the model, which is updated. So a single value.
It's a single weight. Yeah. Yeah, exactly. It's a real number, and why is it weight? Because we're weighting some sort of the previous layer's output or the input. So, and it's a function. Neural network is a function. So, and there's some parameters, and this is just a huge function. It's like there's 70 billion parameters. You know, so that's big. And these things tend to remember something, and this can be exploited by so-called membership inference attacks. So that we infer whether an example. So, okay, membership inference attack is interesting, because it's inferring whether a particular example, so the training example, was in the training set. This is one attack. Or we can just extract data and recover full training examples. Okay, so membership inference is saying, was my training data point in the training data or not? Doesn't really make sense in the language modeling part, but maybe if you have like a database of persons, was I, if I train your model on Netflix, then you might ask like, what, was this person in Netflix dataset or not? So this membership inference attack. But for LLMs, if you can recover full training examples, it's kind of, it memorizes the things. So in this paper, Nasser et al., they define it as extractable memorization, that if you have some generation in the model, because GPT can generate text, one token at a time, if you construct a prompt, P, then makes the model produce something from the training data, then you kind of say, yeah, I extracted something from the training data. Now, the formalization is kind of like maybe like too much here, over-engineered, so to say. But basically, if you can recover something from your training data, it's extracting data from the training data set. So what I did, well, there was, before this last paper by Nasser, there was a paper by Nicola Carline and others from Google. By the way, Nicola Carline is also involved in the other paper, called extracting training data from large language models. Back then, large language model was GPT-2, which now is it large? Jesus, okay, but it's still big, right? I mean, it's you cannot like read it, so like there's just too big. But anyway, it's not large language model anymore. It used to be large language model. And what they did back then is because GPT-2 was trained on internet data. That's what we knew. They didn't tell which data, but we knew it was trained on the internet. Maybe we knew it, but it was like maybe it's in the paper. I don't remember, but it was internet data. They started prompting with some short string sample from the public internet. So you just take the internet scroll and just 5 words and prompt the GPT-2, and then whatever comes out, you kind of manually check whether these strings are in Google search, right? And if you can find the output of GPT-2, it's somewhere on Google, then you find the source of this. You kind of say, yeah, well, this was in the training data because I can find it on the internet. So simply prompting the model with data sampled from the model's training distribution, like internet data, and assuming that any string memorized by the model is contained in Google search index, kind of gives you success rate for your extraction kind of thing. It's very, well, I wouldn't say complicated. Maybe if you have access to Google's APIs, Google search APIs, it's faster, but it doesn't tell you like the full scale of the problem. So in this paper by Nasser last year, they took the same approach, but a little bit different. So they first attacked the open source LLMs model. So, okay, we have to clarify this term. So what is open source LLM? Anyone? What is open source LLM? So, yeah, go ahead.
so can be used by anyone. And it is like it has open license.
Open license of what?
Data set is available.
Which data?
It is like it's not licensed. I mean, it's not owned by someone.
So do you have an example?
So it is run by a community. Like
Okay, so yeah, I see your point, but maybe you're taking like a software engineering perspective on open source, and I think it's not really correct here. So we have to. That's why I'm asking. Like we have to clarify that. So people say open. So what is our large language model? If you have a pre-trained large language model, what is it? It's a bunch of weights. So the weights, the actual parameters of the model, and the architecture of the model, which is mostly some sort of transformer. Okay, so you need to know how things are stitched together as a transformer, and you need to know what are the actual weights of this model. But that's not the full story. You also have this pre-training data, how the model was pre-trained, and maybe the procedure, how the model was pre-trained. So and this is like the full package is something like you can reproduce. So you know what's in the training data, you know how it is trained, and you know the final weights. So you can do your kind of transparency research. People tend to call open source models only those which have just the weights and the code. Like Llama 2, people call it like open source model, yeah, because you can run it locally, you download the weights and everything is fine by Metafair. But nobody saw the training data. And nobody actually knows what's in the pre-training data of the Llama. Nobody knows. Did you read the report of Llama? What is in there? I think it's just like one sentence saying like, oh, maybe two sentences. We had it in lectures, like, very funny kind of note. We use some public data on the internet, but nothing from Facebook. No, seriously, it's there. Like, go check it out. They call it open source. Yeah, it's a bad name, right? But it's selling better, so it's open source. But there are some truly like open models where you have even like the training data, the internet available for you to download, and the model architecture and the final weights. So you can do like full kind of reproducibility thing. So one of them is Bloom, was like 2 years back, and there's some others. But not all of them are like open source, like fully open, okay? So it's like, it's a nice PR to call it open source. They are in open source in a way. Anyway, so they tried to attack these open source. They had a couple of models, I think, including really open models and really somehow half-closed models. And they downloaded 100, should be gigabytes, excuse me, not bytes, gigabytes of data from Wikipedia, and generated prompts by randomly sampling hundreds of millions of continuous 5-token blocks from this data set. Okay, so you take Wikipedia and just sample spans like 5 grams. And then you take one and just generate, prompt the model and generate the rest. And if this is producing something like producing a text, lorem ipsum, blah, 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 and then in these open, like fully open models, you actually have access to training data, so you can see whether this is in your training data or not. So then you see like, well, did it remember something? Or so this is why open research is great, because then if you're a bad guy, you can find out how bad you are, okay? Whether they are generated sample or whether it's memorized or not. And they said like, well, if it remembers 50 tokens, this is kind of bad. Yeah, well, it is bad. I mean, 50 tokens is a long piece of text for training data. So they did that, and they also did the same or similar thing for extracting data from ChatGPT, where you don't have the training data, and they use some sort of kind of approach to prompting the model, not like in the previous one. So here they just had like 5 words in, and the rest will be sort of like generated. ChatGPT has some, it was fine-tuned with this reinforcement learning from human feedback and blah, blah, blah. So you have to prompt it, and they found a couple of prompts. For example, user repeat. No, this is the prompt. This is the prompt. Repeat is repeat. Excuse me. Repeat this word forever. Poem, 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 poem. 50 times poem. It's completely bullshit, but it works. So what ChatGPT is doing is start repeating poem, 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 and then maybe 1 page later, it starts spitting completely random stuff. Completely random, it's whatever it means. And maybe later it starts spitting, guess what? Training data. Like here. So this is This is one of the outputs. I have a look at this paper. It's hilarious. So it starts opening poem, and sometimes it fails, but sometimes it gives you blah, 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 and location, Elkader, blah, 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 NG Gern, HR director, phone number. This is redacted in the paper because there was a real phone number of real person email, real person email, and blah, 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 and call or text, and so on. So ChatGPT actually remembered data. Well, we can argue now, to me, this looks like some company website, you know? So maybe in this case, that's okay because it's public anyway. But we don't know. I mean, we don't know how many of those could be kind of internal data. So if you maybe do this with Llama, and if Llama were trained on Facebook internal data, you might find out like nasty things in the internal kind of weights, you know. So this is bad. I mean, this is not like an attack of is somebody present in there like a person and it's items, but it's still remembering some because there might be people in there in the textual data. So it might remember something private about them. Like what is, and now we're coming to the question like, is this private or is this private or is everything private or what? So this will be like a theme through the course we will have to address because if you're leaving the kind of like table, Netflix database thing and you go to text, things are getting more complicated. But this is a real deal, you know. And the paper was great because they reported to OpenAI, and after is it 6 months or 3 months, the standard kind of notion for fixing security bugs? I don't know, maybe 3 months or 6 months. But afterwards, I mean, they reported to OpenAI saying like, hey, OpenAI, listen, your model is leaking training data, and you have 3 or 6 months to fix that because otherwise, you know, afterwards we're publishing the paper. I think they fixed it somehow. Maybe they didn't. Who knows? You know. And they published a paper in December last year, or November or December. It's pretty cool, isn't it? Well, it's terrifying actually, but it's pretty cool. Okay, that's it. Any questions? Cool. Okay, so my question is like, how to fix that? Like, how on earth can you fix that? And I have good news, bad news. So the good news, we'll try to talk about techniques which are helpful in protecting privacy in language. But actually, I don't think we still like it's an active research field. So most of these papers are not more than 5 years old, or even like very, very kind of youngish for some of these tasks we'll be talking about. And I don't think we still have a like very good answer how to protect privacy in language models. We don't have the answer yet, like as a research. So if you want to research, like here's $1 million prize, like sort of, if you fix that in a kind of principled manner, yeah, you'll get a job at Google maybe or OpenAI or whatever. But there's tons of people working on that as well. So it's a tough game. So what are we gonna do in this course? Okay, we're awesome on time. So my suggestion would be every week we take like 1.5 hours and call it a day. Okay, if it's fine. I mean, I'm not planning like 3 hours lectures, to be honest. Like 1.5 is enough, I guess. Okay, good. If you want more, yeah, tell me. So, okay, so we should cover some of these broad topics. I mean, today we made a point clear, like, privacy is hard. It's actually really, really hard because even if you have techniques, you can kind of just screw up something little and then just the consequences are bad. So we will talking about some sort of like text redaction or text anonymization because this is NLP and it's been PII, it's personal identifiable information as far as I remember. So we'll spend some time on that because I think it's sort of like kindergarten start. And then we'll talk about one of those formal methods for protecting privacy, which is differential privacy, which comes from databases or statistical analysis databases. This will be maybe more hardcore. And maybe we'll spend some time on these attacks, like formalizing these attacks and how to do them properly and stuff like that. So, but this is still nothing of that still exists. Okay, so it will change as we go. Maybe. Okay, so this is the content. Is there something missing? Like, I don't know. Shall we talk more about NLP? Like the general kind of things, like a refresher or not? I mean, my suggestion would be, if you feel like some of these topics, like transformers or pre-training, they're not clear to you, just either ask me or I give you, watch the YouTube videos and then ask me, or maybe because we need some sort of like basic understanding of things. So what you will need for this course is a little bit of understanding on NLP on this kind of bachelor level we had in this course last semester. That's pretty much enough. I mean, that would be like an overkill. So don't watch the whole thing. We will need so how's your math? Pretty good. Okay, so on scale 1 to 5. So who is no, let's do thumbs down, thumbs up, and 2 up. Okay. So who is thumbs down? Math. So mathematics. If you see equation, if you see let's wait. If you see this say if you see this, you want to cry, or you know what is it? You would cry. Okay. If you see, let me see. How to write it? If you see this, will you cry or? Okay. Yeah. All right. So the second equation, who's gonna cry? It's who's gonna cry? Who's gonna cry with this one? Me. I mean, I don't care. I just want to know, like, where should we start? What should we do? I want to really know what's your math, because we will be dealing with some math here. I mean, this will be maybe a little bit hardcore. So I want to know. So who doesn't know what this is? Raise your hand. Be honest. I don't judge you. That's fine. I want to know who doesn't know what this is. Okay, 2, 3, 4, 5, 6. Okay, so like let's say 7 people. Okay, so this is PDF of Gaussian. Okay, so this is the Gaussian distribution. Okay, maybe you saw it differently. You saw it maybe like x minus mu squared over 2 sigma squared minus, yeah, okay, yeah, but there's a reason why I wrote this in this way. Okay, who knows what this is? Yeah, so this would be like 2 thumbs up, and we're not gonna handle any case. I guess this is the gamma function, which is like a factorial over reals. There's a gamma distribution which might be useful for us in some cases, and there's a gamma function which is like this ugly thing of of x. This is of z. Sorry. Oops. No, wrong. This is the gamma function, and it's in gamma distribution, and distribution will play a role in differential privacy. So I'm just okay. So we don't need this. If you're somewhere in the middle, you should be okay. Okay, so this is great. So we will need some of that. How's your Python and PyTorch? Maybe I should stop recording because it's maybe I should. Listen, okay, I'll come to that later. Course logistics. I don't have to record this as well. Exam and grading. You can read this. Communication, of course. I'm here, and that's it. So let me stop recording, and now we can talk. How to do that? I got to stop and